All right, so we learned about these quantum numbers and how they tell us where an electron is located. So let's take a look at the shape and size of some orbitals, and we're just going to look at the s orbital. So we're going to look at a 1s orbital, a 2s orbital, and a 3s orbital. Remember, this number right here is n, right? So n equals some number, 1, 2, or 3. And then this letter designation is from L equals 0, right? We're talking about s orbital, so we're talking about L equals 0. So if you take a look at a 1s orbital, the s orbitals, as we previously said, are just spheres. They're just spheres, right? And so there's a probability that the electron is going to be somewhere in this sphere. And so we can also draw a chart. Right on this y-axis, we have probability, right? And then this is distance from nucleus. So this is like 0 picometers really close, and then 1,000 picometers. So it can't be at 0 picometers because that's where the neutrons and electrons are. So the probability of it being right at the nucleus is 0, and then it skyrockets up and then just kind of goes down like this, right? So this is the probability that you're going to be somewhere in this yellow sphere. So let's see what happens when we take a look at a 2s orbital. And so the n equaling 2 will tell you that now it's bigger, but let's take a look at how exactly that looks. So you're still going to kind of have this inner sphere where it could be, and then after that, you're going to have what's known as a node. The node, the electron cannot be in the node. So this right here in white is the node, and there's 0 probability of finding the electron here. So 0 probability of finding the electron here. And then outside of this node, there's going to be another layer, and then there is a probability that you're going to find the electron there. So if you talk about the same chart we have here, now we'll see we have a little hump corresponding to that inner circle, and then we have a node, so we have a 0 probability, and then we have the bigger hump showing the blue circle, right? So this part here is in orange, and then this part here is in blue. So as your orbitals get bigger and bigger because the n increases, you start having more and more nodes. So then let's think about 3s. In 3s, we're going to have 2 nodes. So you'll have the probability that it's somewhere right in the center. Then you'll have a region of 0 probability, and then some probability that it's going to be kind of in this outer layer. Another node, so another region of 0 probability, and then finally an outer layer where the electron can be. And again, so if we take a look at the probabilities here, it looks something kind of like this, right? Where this little one is the orange. Let's see, then I went with blue right there, and then green right there. So as n increases, we get bigger, and we get kind of like layers of an onion, right? We start developing these layers. And so these nodes, if you kind of think about it, it does actually make sense if you consider it as a wave, right? So we talked about this a little bit before, but we can see that waves have these nodes, right? You have a node right there, you have a node, you have nodes, and you can see there's no wave there, right? And so that's kind of the analogy that we use here. But really what I want you to know is n increases, our orbitals get bigger and bigger, and they have this kind of layering look to them. It's kind of the same thing I was drawing, just slightly better picture. So you can see the 1s, the 2s, and the 3s orbital there, right? Same pictures we were drawing, and then this right here is probability, right? The probability that your electron is going to be there.